Well, good afternoon, everybody. Let's start in Dutch. I'm sorry, Armin. I will start in Dutch. Goedemiddag allemaal. Goedemiddag allemaal. Welkom terug. Conferentie Bits, Bricks en Behavior Week van de gebouwautomatisering. Wij gaan door met ons programma vanmiddag. En ik ga schakelen naar het Engels. I will change to the English language by now. Well, you're online. Armin Anders, I will introduce you. You're the co-founder and business development manager of EnOcean, located in Germany. Welcome.
Welcome. Thank you. Same to you.
Thank you. Well, as I told you, we talked already. As I told you, I won't make a long introduction. I will leave it all to you so you have enough time to do your presentation. Your presentation is called IoT Smart Spaces for your buildings and homes based on self-powered wireless technology. I'm very curious. The floor is yours, Armin. Thank you.
Okay, thank you. Hello. I'm Armin. I'm from EnOcean. EnOcean is a technology company based in Germany, in Oberhaching. That's south of Munich. And probably let's go here through. What I would like to present you is buildings and homes with self-powered wireless technology that enables IoT applications, smart spaces. First, I would like to start presenting the technology that is behind, the secret ingredients. Then I will go to the use cases, present you benefit, devices, and references of the following use cases as building automation, smart office, smart cleaning, energy saving, healthcare, ambient assistant living, safety and security. Or that are some, let's say, the most active applications that are currently dealing with buildings, homes, and commercial buildings. Last but not least, I want to present you that IoT is ecosystem, so much more than only devices or applications. There's a need to get a whole ecosystem together, and how EnOcean addresses this. First of all, as I already told, EnOcean is a company placed in Germany in the south of Munich, Oberhaching, between Munich and the Alps, but more to Munich, of course. We are dealing with energy harvesting components, modules, and devices. That means the sensors in these IoT systems shall avoid batteries, How this will work, I will present you with the next slide. Status is that EnOcean has subsidiaries all over the world. And in the meantime, we have been founded in 2001. First products have been available in 2003. And in the meantime, together with our ecosystem, with our partners and solution providers, we have now equipped more than 1 million buildings worldwide. But first of all, what do you have it? What's the benefit of a user that is using IoT solutions? In general, you can realize 50% cost reduction of building automation by using wireless. You can realize 30% energy saving by single room control. 25% space savings by shared desk applications, 20% less cleaning or sterilization effort by demand-oriented cleaning, and last but not least, 15% higher employee productivity by healthy and comfortable environments. And these are exactly the things what I would like to address and speak with you in the following. But first of all, let's go to the mission of EnOcean. These IoT solutions says that there will be a huge amount of sensors in the future needed in buildings, outside of buildings, smart city, and so on and so on. And if you add all the sensors, there comes immense numbers here. And the question is now how to connect them. And there's only one option, and this is avoiding cables, doing this wireless. Wireless in the past, next is here, wireless in the past always needed a battery to power the wireless sensor. And here we are using a secret ingredient, and this is small energy generators, power energy generators that generate the energy for the wireless units to replace the batteries. This could be either an electrodynamic generator usable for all the switches. Kinetic energy means a magnet in a coil is moved. So if you push a button or something is moved here by a machine or something like that, there is kinetic energy, and this you can use to power the switch. If you don't want, for sensors where you don't want to wait until somebody pushes a button, at least there where people are living, some solar energy is a very well suited energy. And in that case, we are using small solar cells that collect the energy during daytime or as long as it's available. And for the dark time, capacitor and energy store is loaded also to provide 24/7 operation of the sensor units during total darkness. The third energy source we are using is thermal energy, mainly with HVAC applications or industrial automation. Thermal energy is very, very power efficient by Seebeck effect. You can transfer the temperature difference between the machine or the heating valve and the ambient to electricity that powers then not only the radio. In that case, you have so much energy left that you even can power an actuator, and this is here a heating valve actuator that can be connected directly to the radiator and does not only the temperature difference of the radiator versus the ambient, does not power only the radio, it also powers the valve itself. Last but not least, the fourth energy source we have in mass production is magnetic field energy, to measure the current of a cable by the magnetic field energy, and this energy also powers the sensors. So that was the technology behind. Let's go now to the applications. That should be interesting for you. Building automation, is that what EnOcean is doing now since 17 years? Since 2003, we had the first products ready for shipment. At that time, we equipped the headquarters of Bosch Siemens Household Appliances here in Munich. In the meantime, a lot of other buildings have been equipped by this wireless sensors. For example, this Torre Espacio here in Spain, 20,000 wireless nodes in all. What are the wireless nodes? It are the sensors and switches that control HVAC, shading, and lighting. And the motivation, the main motivation to use those wireless devices are flexibility and cost reduction. Flexibility means that such buildings are not rented at once. They are rented part by part. They have open room structure inside, and the separation walls are coming in as soon as the renting people are moving in, and shortly after a short time, the first reconstruction already is started. So flexibility demands for wireless units and cost reduction. 50% of new installation is a clear source. It means clearly by saving wiring, because building automation needs a lot of wiring if you do it only by wires, because you have to connect every switch, every actor and everything with one central control, the building automation controller. And doing this wireless saves a lot of cabling effort, and this means reduces dramatically the installation costs. Flexibility also, if you see that 99% are existing buildings, retrofit of wires is anyhow very difficult. So in that case, for retrofit, wireless is also very appropriate. I have to be here. Here are some examples of buildings that are equipped with self-powered wireless sensors. This is the Square in Frankfurt with 18,000 wireless nodes all over this building. It's like a high-rise building, only tilted. It's called the Square office buildings and hotel rooms. In that case, here the Torre Espacio and Torre Cristallo, both units, both towers in Madrid, as an example, 20,000 self-powered radio nodes each. This is headquarter of SAP in Waldorf. Other examples are headquarter of Nestle in Paris, the airport in Toronto, hotel in Singapore, and so on and so on. Those are mainly the more impressive buildings. In the meantime, the most of these units are addressing the residential market. For this is example here, this is a pre-manufacturer homes manufacturer in Germany. He is using this self-powered wireless technology as a standard for all his buildings. And you can imagine, wireless is clearly for homes to set them quickly up. Wireless makes a lot of sense, and the key application is anyhow central commands like all blinds up and shutters down and switch off all the lights in the building and so on. So central functions demand normally a high amount of cabling, and wireless avoids this cabling, speeds up installation time. So wireless makes a huge amount of sense in residential buildings, in pre-manufactured buildings. And you can imagine if somebody sells a house, you don't want to sell it with 20 batteries inside. So that's the reason why the self-powered makes a lot of sense for residential, and because the volume is so high, in the meantime, we sell the most of our components in the residential. Now we are addressing new applications, not only the building automation. Now here is one very, let's say, public application. Now this is the smart office with benefits like space savings, productivity increase, and last not least, in the moment, the social distancing is a very important thing. Here are some numbers. Before Corona, there already have been a lot of not used space office because the people were at the customers or something like that. And now during Corona, of course, the space offering is even much more, and the savings are even much more. What components are needed for smart offices? Of course, with respect to Corona currently, but not only to Corona, you want to know how many people how the people are distributed within a building. This you can do by counting the people passing at a certain place. You can do it by measuring the people activity at certain areas. For generating a heat map, you can measure the number of door activations that correlates also to the number of people, at least at places where not a lot of people are running through one door at one time, for example, restrooms. And with the desk utilization, you can also measure the number of people that are currently working in a dedicated area of a building. This desk utilization sensor also is a basis for shared desk applications, and shared desk application also, it makes sense, and this is a very new unit now. This is an e-paper that is powered by a solar cell that gives you information about the status of the desk. Is it booked or is it free? Has it been used, or has it to be cleaned, and so on, so that you have this information not only in the cloud. In that case, you have can also present this information directly at the desk. For meeting rooms, you need a room occupancy sensor, and outside of the room, it makes sense to give you information about the status of the room. Is it booked? Is it empty? Is it free? Or has it to be cleaned or something like that? With respect to Corona, currently CO2 sensor is a very important thing, because the CO2 correlates with aerosols. And so here, at least in Germany, there comes up more and more the demand and the requirement also of public authorities that we have to place CO2 sensors in public buildings, rooms, schools, and so on. And this is a traffic light that shines directly at the place where it is, whether it's green, is it yellow, or is it red? And if it's red, you have urgently to open the windows to get the air clean. Some more sensors here. I don't want to dig all into details that are important to make the offices smart, to measure the comfort and the healthy environment. Now, one example, this is here in Dresden, the T-Systems building here. This is equipped by T-System themselves with desk utilization sensors. And here you see an example of them, how they deal with the data and analyze the data here over time, and heat maps, and here percentage of they generate percentage numbers, and so on to give you information about booking status and usage status and air condition status. In that case, this is another example where this technology is built in. This is Cube in Berlin, a very innovative building. Here you see a floor plan of this Cube where they use these activity sensors to generate a heat map. Here on this, you see where the booked or free places are at the location. And they also here you see a PC board that even gives you information about not only where's the biggest activity. They also count with this activity counters. They make a people count out as a data basis for further usage. The next very, let's say, variable application is smart cleaning. What's the value in it? The service transparency. You get a high or a written information back how the cleaning has been done, how often the cleaning has been done. So it provides service transparency, and in addition, we have a number that demand-oriented cleaning. So taking care about how many people have been where, you can save cleaning costs and considerably. This is respect with to office rooms and lounges, where you can count the activity in a meeting room, or the device utilization of tables and also boards or something like that that indicates it has to be cleaned or disinfected. And door activation, at least for restrooms, you can use as a people count and a passing counter, of course, where more people are walking in and out, like airports or something like that. Service button is always a very good thing, because you can't measure all waste with sensors. So to giving the information that special cleaning is needed is always a very beneficial thing. Last but not least, status sign outside of the rooms gives indication about has it to be cleaned or not. In addition, you see here dispensers that have sensors included that gives information about the level of the towels, of the paper, of the disinfectant, and so on. This correlates in a certain amount with the activity, people that are walking in and out. But if you want to have it in more accuracy, this makes also sense to have sensors inside. So it depends a little bit on the needed accuracy, how many sensors you want to add for an application. Here you see these are dispensers with integrated sensors, and this information you can either bring to a standalone dashboard. So this is CWS, they're offering here a standalone solution, but they also offer this data in the cloud, so that service or system integrator can use this data. In that example, it's Apleona, where they have equipped the location with this dispensers, and here on this board, on this display, you see the level status of the dedicated dispensers here all over the building. So interoperability is very important, not only a standalone system. It makes absolutely sense to bring this information also to other systems that improve applications. I like also this wording here, addressing the current situation, that washing your hands is very important. But in that case, it's clear that also it has to be granted that the filling status of the utilities are given. This can be done by this. The next key application is energy saving. Energy saving, mainly the single room control, gives up a very reasonable possibility to save energy costs and make the buildings green. In that case, of course, you have to measure the status in the certain rooms by thermostats, by presence detection. If a window is open, you can shut down the heating or the cooling and so on. Air quality is important. But in that case, not only sensors, because the information about the status does not improve the situation. In that case, it makes absolutely sense to include also the actuators into the whole process. And we have already spoken about this one, the heating valve controller, the thermal powered one, that adjusts the radiators for a temperature that is needed. These heating valves are very, very popular here in Germany or in Europe. In other states, for example, in the US, they do it with air. So in that way, you have to control not the water, but the airflow. This can be done here by variable air vents. Or in France, for example, where you heat or cool with electrical energy, you need only electrical heater controllers. This is a nice building as a reference where this is done here. This is in Abu Dhabi. Energy is an important energy saving is also in Abu Dhabi an important thing because we want to go down with our CO2 footprint. This is Abu Dhabi building, very famous here. You see it and very impressive. And there's here the IBM part is equipped with energy measurement and also presence detection and so such sensors. Although the commercial buildings are always so impressive, the volume is coming from the residential market, from the homes and the flats. And here is an example of digitization of flats. Here, 3,000 flats in Berlin. The main driver was energy saving for this installation. Here you see the radiator and the retrofitted thermostats at the entrance. There is a board that controls the heating valves, but also gives the possibility to the renters to interact with the tenants to interact with the facility management of this building. And the nice thing is because everything is so easy, it's wireless. You only have to screw it to this one here, to screw it to or replace the existing radiator valve. This one here is by 2 screws. You can mount it to the next to the door, and so an installation of one flat is done in less than 40 minutes. If you want to have some more information, I have also added the link here, where this project is described in more detail. Other important applications, IoT applications, are healthcare, safety, and security. Only to giving you an impression about several sensor and actuator examples you will need. Here for ambient assisted living, you want to know the people activity, what they are doing, and if this is different than normal, by the abnormality you can react. With this presence detection, you can also say, oh, so nobody should be inside, so there is a problem here inside. Emergency buttons for elderly people are very important here for safety and security, window status, and also, water is mostly more worse, or is sometimes more worse than fire here. So to detect open windows and set them in correlation with, for example, rain. what the cloud do. In the cloud, you have the information about the weather status, and if you bring it together, you can inform the facility manager to close the windows, or you yourself at your home. Lock status of door locks or of these ones here are only some examples. Water leakage is a very important sensor because, as I already told, water is mostly even worse than fire. Everybody who had already a water damage in his house knows what I'm talking about. This sensor is a self-powered sensor. This doesn't need batteries. If it's getting wet, expanding disks press to a kinetic energy generator that powers then the radio signal and gives the information to your mobile that there's water leakage. And in addition, if you are somewhere else and you can't access to your home, it makes absolute sense that it is also connected not only to your mobile, it's also connected to a water valve also that switches off the water so that no more damage can happen. These are two examples for ambient assisted living. Here you see pressure sensors, kinetic powered pressure sensors located in a mattress to give you information about the elderly people, what are they doing and when they are doing. Same concept is behind this other application, Carantis, that's located in UK. This is located here in Germany. The thinking behind is always the same. If there is an abnormal activity pattern of the elderly people in a home, then you inform the service people and you, the relatives, about take care. He has could have done something wrong, and then you can call or directly send somebody to the place. And because Pa and Ma even longer want to stay in their homes, this is a very important application for the future that gives the possibility that the elderly people can even longer stay in their homes healthy, and if something happens, that the help, the support is informed very, very quickly. In buildings and homes, of course, metering is an important thing to give you information about the consumption of gas, water, electricity. This is also a very interesting thing. This is a scale that measures the weight of something that you have put it on. This one here is dedicated to measure the weight of a CO2 bottle, and the weight direct correlates to the filling status. So here the filling status via a weight measuring of a CO2 bottle is done by this unit. You can also put this beneath paper bins or something like that, because the filling status of the paper bins also correlates with the weight. Even better than sometimes you can also measure via the filling status via distance sensors. But if you have only one paper in the basket and you measure only the filling status, and this paper is unhappily in this paper bin, then it already indicates that the paper bin is full. So weight is a much better indication for the filling status also of waste boxes. These are sensors that are implemented in driveways to give information about the status of parking lots, so for parking management. This is a kinetic powered sensor that is implemented either in a rubber tube that's glued onto the concrete, or you can also put it into the concrete. So it gives you information about also the information about the direction of the car who is moving. Preventive maintenance, some examples here. This is a thermal powered preventive maintenance sensor that measures the temperature. All machines, brakes, gears, pumps, and so on, if they are working, they have a dedicated temperature, and this temperature you can, first of all, it's a change of this temperature. An abnormal change of this temperature gives you information about the status of the engine. But this temperature you can also use to power this sensor itself. Current monitoring also for preventive maintenance, because the current changes if the motor goes back. Some more examples, what's in buildings, around buildings. You can address here retail by people counting, and here you will see exactly the same things again. Temperature sensor, people passing counters here in buses, bus stops, or to measure how many people are in a certain bus or something like that. Manufacturing logistics, only to give you an impression of applications that need sensors. Now, we have spoken a lot of about sensors. Of course, you need also a cloud connectivity, and this is mostly done by active radios that collect the information of the sensors, and the actuators brings the information to the actuators. This could either be an active antenna, or in that case, we have now also a partnership with Aruba, where in this Wi-Fi access points, you can simply put in an USB receiver, radio receiver stick, so that this access point also can communicate directly with this with the sensors and actuators. If you need a local, let's say, control, you also need a local gateway for this information. You can either use directly the building automation system if you have access to it. If you don't have access to it, then you have to place a dedicated gateway, which then brings the information into the cloud. If you don't need local control, you can also give this information directly in the cloud, so that it's accessible. And now it's very important by IoT that you address all the different kinds of clouds, whether it's Amazon, whether it's Microsoft, IBM, Google, or something. So in this case, it has to be very open to address all the different technologies that are located in the platforms of the internet. And then, of course, you also need an application. And this application then takes care for visualization and control backwards the local intelligence, and so on and so on. So this is the architecture of the cloud side. Now I am going slowly to the end. I have spoken a lot of applications now and of devices and connectivity. So, but this is only one bubble in the whole IoT world. We have also spoken about cloud platforms. There has to be very open about the clouds, which kind of clouds, also the devices. There are a huge amount of different devices. It's not only EnOcean, this could be also other radio technologies and so on. At the end, to realize an IoT system solution, you need a lot of different, let's say, competencies to bring together. The data alone is not sufficient. You also need an application, at minimum a visualization, but a connection to a process optimization or something like that, even better. So you need an application, somebody who brings all these things together, so a system integrator. And at the end, you have also to install, commission, and maintenance the whole system. So this is a lot of different competencies that has to be brought together, and this is to be addressed by an ecosystem with open interfaces, clearly defined, how these things could communicate with each other. And this is an example of such an ecosystem. This is the EnOcean Alliance, where 400 companies worldwide are associated with each other. And this are not only, let's say, sensor providers. These are system integrators, application providers, planners, real estate companies, facility managers, and so on. They are located under one umbrella. Brought them together, and here you see that are the promoters. The promoters are T-Systems, Microsoft, IBM, Honeywell, Taco, Engie, and those together have defined 5,000 interoperable products, more than 1 billion buildings installed worldwide, and they are standardizing all the interfaces in this complex ecosystem and offer also total solutions to clients. Yeah, more or less I am done. Hopefully I could motivate you to show you, yes, the solutions are available. The technology is given. So the major thing now is, roll out.
So, am I visible? Okay. Are you still there, Armin?
Excuse me?
I just asked, are you still there?
I'm still here,
yeah. I know, because you're answering me.
Yep.
I saw that we have some questions in the chat. But unfortunately, I can't see them on my iPad, so I'm walking towards the computer so that I can see them. Well, let's see. I have a question, and that's also a question of me, so nice to ask that. Could you share the presentation? Is it possible that we share the presentation with the people who are visiting this session?
It was very.
I mean, in a PDF as a handout.
Whether I will share this?
Yeah.
Yes, of course.
I will send it to all the viewers.
Yes. No, the PDF, no problem. Yes, it's appreciated.
Yeah. So, another question from N. Scheffer. Could you explain if all sensors and devices are from one or more brands and how to connect all those products into a BMS? What do you need for hardware and software?
First of all, it's a technology that is standardized. So these functionalities are offered from several different manufacturers. But the interfaces are clearly standardized so that you can use a sensor from Honeywell or use a sensor from Thermocon or El Taco. They speak the same language. On the receiver side, you need a gateway that brings this information into the BMS. But all those gateways are available in the market to all different BMS systems, whether it's Connex, Lone BACnet, DALI, and all those things. Or you can use a gateway that directly brings the information into the cloud without a BMS. Both is possible.
Okay, thank you. Another question from Koen Miolet. Can it deploy different bands depending on spectrum available in a particular country?
Did not got it. Can you repeat?
I will repeat the question. One moment. From Koen. Can it deploy different bands depending on spectrum available in a particular country?
We are from our side. We are using 3 different frequencies. This is 868 that is available all over Europe. We are using 902 in the States, and 928 megahertz we are using for Japan. So yes, there are different brands, but you can mix these brands with each other as long as the radio frequency is approved in this dedicated countries.
Okay. Thank you. Let's see. Do we have another question? Because we have some time left. What spectrum or protocol does an EnOcean sensor deploy?
It's so disturbed.
Oh, sorry. What spectrum or protocol does an EnOcean sensor deploy?
Yeah, the wireless protocol.
Yeah, I think so.
Yeah, it's an ISO protocol. It's a standardized protocol with an ISO IEC. The number is 18456 or something like that. So this is standardized protocol. The sub 1 gigahertz, as I already mentioned, 868 megahertz in Europe, 902 in US, and 928 megahertz in Asia. The advantage of sub 1 gigahertz in buildings is clear. Sub 1 gigahertz versus 2.4 gigahertz has a much better material penetration characteristics. So you can even go through walls with this radio or through people. So you are not limited to, let's say, one in-room use. So you can penetrate walls, and typically you have up to 30 meters range within buildings.
Okay. Well, I hope that will answer his question. Let's see. Do we have another one? I think we have them all. Oh, wait. I see another one. Again from Koen. Is the energy source on a sensor, i.e. kinetic, thermal, etc., either one or the other, or does a device contain all energy harvesting options by default?
No, either or. Because otherwise the cost will be too high. So the energy source always is related to the usage of the sensor. So for a switch, we are using in general kinetic energy. So there's not a need to add an additional solar cell at the switch, because if you operate the switch, then you have this kinetic energy available. Solar energy for the sensors, yes, you could imagine that you implement for for dark places also another energy generator, but we don't do this. We power it by the solar energy, and in cases where this sensor really does not see any light, you will have the possibility to insert a backup battery for these cases. But as long as you have a little tiny light energy available, this will power the sensor.
Okay. Thank you. Well, I don't see any more other questions. Well, do you have anything that you would like to say for a closure?
Yeah, you're welcome. Here is my contact. Directly send me some requests to me. They are welcome.
Okay. Well, thank you, Armin, for your presentation. It was very interesting. If you don't mind, I will change to Dutch again, so I can make an announcement for the next session this afternoon.
You're welcome.
Thank you. Wij gaan zo meteen verder met de volgende sessie. Als u zich daarvoor heeft aangemeld, bent u hartelijk welkom. Ook als u zich nog niet heeft aangemeld, het is nog mogelijk om je gewoon aan te melden voor de volgende. De titel is The Fifth Facade. Is het Engels? Ja. Ik doe mijn best. Protect Against the Environment. The Fifth Facade, Protect Against the Environment. Het is een verhaal over het Building Management System in het licht van een digital twin. En het gebruik van live data en verschillende opdrachten daaraan gekoppeld. Zometeen om 2 uur. Ik zie u graag terug. Tot dan. Hi.